Hey guys, this next chapter we're doing is all about circles. So we're going to first talk about some different segments and pieces and parts of the circle. So the first one we're going to discuss is just what a circle is. It's the set of all points in a plane that are equidistant from a given point called the center. So in this case, the center of the circle is C, so we call this circle C. Or we can use this with the dot and the circle around it, C. So circle C is your shorthand for writing that. Part of the circle that you should have heard of is the radius, and the radius is a segment whose endpoints are the center and any point on the circle. So we're going from that center point C out to the edge of the circle. So there's a couple different ones that you could pick, but CA, and it's a segment, so I'm going to put the bar above it. You could also use CB as an example. A chord is a segment whose end points are on the circle. So again, we're looking at a segment. So it looks like to me AF would be a chord. Another chord would be AB, but AB has even a special name, the diameter. It's a chord that contains the center. So AB is a chord that contains the center. So it's a segment that contains the center. A secant is a line, not a segment, it's a line that intersects a circle in 2 points. So AF intersects in 2 points, but instead of it being a segment, it's a line there. So we're going to include all of those points that go past A and F. And then a tangent is a line in the plane of the circle that intersects the circle in exactly 1 point. A line in the plane of the circle that intersects the circle in exactly 1 point. So I noticed that bottom line there, EBD, would be a tangent line, but we can't call that by all 3 letters, so you just pick 2 of them. You can call it EB, you can call it BD, whatever you would like, just pick 2 of the 3. One thing you also need to know is that point B is called the point of tangency. Point of tangency. So now, for example, when it says tell how many common tangents the circles have and draw them, you'll want a straight edge here so that you can line this up. But common tangents means how many ways can I draw just one line that's going to touch both circles at just 1 point. So right here along the side, and you should be using a straight edge so these lines are a lot nicer, would be 1 tangent. Right here along the side would be another tangent. And then right here in between would be a 3rd tangent line. For B, we still have those ones along the side, just like on A. But I don't have any going through, so this one only has 2. For C, I only see the tangent line where these are touching here in one spot. So 1. And then for D, there's nowhere that I can draw one line where it's touching both circles at only 1 point. So this one has 0. Okay, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its end point on the circle. In the diagram, RS is a radius of the circle. Is ST tangent to circle R? So we have three lengths, and it looks like it might be a right triangle. It definitely is a triangle. But our previous theorem just told us it has to be perpendicular here to be able to show that. So we could set up that Pythagorean theorem table that we used a few chapters ago to determine if that really is a right angle. Is it really perpendicular? So we would do c squared on one side of the table, and then a squared and b squared on the other side of the table. So we would have 26 squared, we'd have 10 squared, and we'd have 24 squared. So now if we plug those in the calculator, we get 26 squared to be 676. We get 10 squared to be 100. And we get 24 squared to be 576. So 100 plus 576 is 676. So since those are equal, then we can say yes, it is tangent because that is a right angle there. Okay, our next theorem says tangent segments from a common external point are congruent. And you can see that below in the picture, that RS and TS are congruent to each other. So they're both tangents and they're going out to the same point. So that means then that we know that if RS is tangent to circle C and RT is tangent to circle C, then we can find the value of x because we know those are equal to each other. So we can say x squared equals 49. So if I take the square root, then I get that x equals, you need to be careful that you include both answers here, because remember that when you take the square root, it can be a positive 7 or it can be a negative 7, because negative 7 times negative 7 would give you positive 49. So x is plus or minus 7. Alright guys, if you have any questions on this, come in and see me. I'll see you in class.